Hello everyone, welcome to Can.Do.So. This is Ready. In this lesson, we will learn the proportion z-test. First, let's load the packages we will use in this lesson. This one, tidyverse janitor, will help us to use a table in tidyverse, and OpenIntro will help us to draw a plot of normal distribution, and the card data is the data package. So proportion z-test is a hypothesis test for the population proportion. It is used to test categorical data. So let's go to the R. Mm-hmm. We can see that the first see the take a view of the here gender is a categorical variable which only take two values, one is female and one is male. So with categorical data, there's no big number or maximum number or quarter. We just has a proportion. So if we use this one, this is just a count. Female is 812 and male is 713. If we choose a age as a numerical variable, it will tell us the minimum, maximum, median, mean, third quarter, and first quarter. So we have also, and this one works the same as summary one, but normally we use this one table. Okay, we can calculate the proportion of male and female. You can see that is this function. You can see it's female is 0.53 and male is which is 1 minus females percent. So these two must add together. It must equals to 1. These two equals 1. So we can use a bar plot to show the distribution of the categorical data. As I'm sure you have been very familiar with it. If you have watched the previous video tutorials. So now let's do the one proportion z-test. So this data set is just a sample of the total voting data population. So we want to know if this proportion, female is 53%, is different from the real population proportion. Here we don't know that, but we can assume that normally maybe female and male will be normally roughly equal. So here we assume that the population gender proportion is 0.5. So we create a hypothesis. The null hypothesis is that the population proportion of female is equal to 0.5, and the alternative hypothesis is that the population proportion of female is not equal to 0.5. So here we can find out here z is a test. Z is a test statistics. Z score. P1 is here. P1 is a sample proportion, which means here is a female's proportion. And P0 is a hypothesized proportion, which is 0.5. We assume that. And N is a sample size here. The sample size is 1,525. And the SE is the standard deviation, a standard error of the sample proportion. And sigma, and the standard error is standard deviation of the sampling distribution and divided by square of a number of sample size. And the sampling the standard deviation of the sampling distribution, we can get it from P0 times 1 minus P0. Here P0 is 0.5, of course. Okay, we got everything we have, and so now we can test it. So without R, we have to calculate these numbers. So they are 1,500, so that's not easy work to do to calculate it. But with R, we just with one click. Here, X, the first is the number of success. Here, we concern is the number of female, actually. And the second argument is the sample size. Here is 1,500. P is we assumed proportion of the population proportion. And the alternative is two-sided. Okay, we can see the outcome. We find that the p-value is 0.01, which is less than 0.05, which is less than the normal significant level, which is 5%. So this one is less than 5%. So there is less than 0.05, of course. And here, this one, can we see, does this contain the 0.5? It does not. So the two things tells us we have to reject the, so we reject the null hypothesis because p-value is less than the screening level and the confidence interval does not contain the hypothesis proportion of 0.5. Okay, it's very easy. Just use this one, this function prop test. Here is a one proportion z-test. What does that mean? One proportion test, which means we only have one. We don't compare this proportion to other proportion. We just compare the samples proportion with the population's proportion. Because the sample is also come from the population. So it's just one proportion they test. So, and we can see what's this means. What happened? There's no. Let's see. We open it. It happens sometimes. This happens. So let's read it again. And run it again. And still not moving. Okay, sorry. It's actually it works. It works. You just to choose it too. Okay, we can see that uh, the blue size is a confidence interval level, and this one is a cart, which means we get a sample. Its cart is greater than this side, and this area is 1.1.209 divided by 2, and here is also PYU divided by 2. So the both sides is out of the 0.5% significance. Okay, we can also change the alternative hypothesis to less or greater by adding the argument less or greater alternative, because in this case, the sample proportion is greater than the hypothesized proportion because it's 0. You see the 0.353. So we can use the here it's not, so we use the it's 0.5. And in this case, oh no, not this one. Oh, here should be greater. In this case, it's still less than 5%, so we still reject it. Which means it is greater than the oh yeah. Okay, sorry for the mess. First we used the 5% significance level, and now we change to 1% significance level. So we change the argument confidence level to 0.99. So we run it. You see that this does not change, p-value does not change, but confidence interval changed. Here is does not cover 0.5, but here it does cover 0.5, and the p-value is greater than 1%. So both values tell us that we should not, we fail to reject the null hypothesis. And also we can change the alternative hypothesis to less or greater by adding the argument less or greater. And since the sample proportion is greater than hypothesis proportion, so we can use the alternative hypothesis as greater. And here. So this one does not change. Now it's still 0.5, but this one changed, and p-value also changes because p-value is less than 0.1 or even 0.5 or even 0.1, so we reject it, the null hypothesis. So which means the true proportion is greater than 0.5. We reject it. Okay, And we can also change the hypothesis proportional to 0.6. So for example, maybe we assume that females proportion is greater in the population proportion, which is 0.6. So we can change this one to 0.6, and we see what's happened. And you see, in this case, the p-value is quite small. So we reject the null hypothesis. So which means the proportion, the true, we reject, so the true proportion is not equal to 0.6. Okay, that's one proportion they test. Let's take a look at the two proportions they test. The two proportions they test is a hypothesis for the difference between two groups, the proportions. So the null hypothesis is the proportions in the two groups are equal, or the alternative is the proportions in the two groups are not equal. Here we can take a look at so the score or the test statistics could be find in this formula. P1 is a sample proportion of group 1, and P2 is group 2 proportion 2, and the P is the pooled proportion, which we can calculate by through this function. Oh, here. That's it. It's just I show you in this case. P equals to P is equal to P1 N1 plus P2 N2 divided by N1 plus N2. Yeah. Okay. Okay, I'm going to show you examples. Let's see, we have one group from the British, from UK. It's 1,525. And let's see, we have another sample. This is just a fake one. I just created by imagination. So which is voting data of USA. The gender proportion is female is 3,120 and male is 2,880. So the total sample of USA is 6,000. And we can easily use, we don't need to calculate it by this. So we can easily use R. And the first X is the first group, and this one is a female, and this one is total, and this one is the second group, and this one is female, and this one is total. Okay, I made a mistake. It's here. The first argument is X is the first one is group 1's female, and second one is group 2's female. So this is UK's female proportion, and this is USA's female proportion, and this one is sample size of Britain. Yeah, it's 1,500, and this one is sample size of USA, which is 6,000. Yeah, here. Then we run it, and the two sample test for equality of proportions. with continuity correction. And we can say that p-value is 0.4. It's quite bigger than 0.1 or 0.05. And the confidence interval contains 0. So the two values, both two values tells us that we fail to reject the null hypothesis. So the two proportions are equal, is not significantly different from each other. So since I have mentioned the continuity correction, we can try one. Equals to force. You see that without continuity correction, and this p-value is still greater than normal significance level. And here is also contains 0. We don't need to worry about this so far. We might cover this with correction or without correction in the future courses. Okay, so that's it. That's today's course. And as usual, please leave a message below if you have any questions or suggestions, so I can improve my video. And if you think it's a great course, please share it with your friends and then like it. Okay, see you next time.